Homework 8, question 1. So the question is telling us that given x of t is the WSS, which is the y-sense stationary process with the E of x of t is equal to eta, which is a constant right here, and then the R of x t1 t2 is going to be equal to Rx of tau, where tau is going to be equal to t1 minus t2, and also let y of t equals to the derivative of x of t. So A, find the E of y of t. So we know that according to the question, that it gives us that y of t is equal to the derivative of x of t. So the E of y of t is going to be equal to the E of the derivative of x of t, which is going to be equal to E of the derivative of x of t, and you do the derivative of the whole thing, which is going to be just the derivative of the eta. And we know a derivative of a constant is equal to 0. So the E of y of t is going to be equal to 0 because eta is a constant. B, find the E of x of t times y of t. So we know that the x of t is the WSS. Because of that, so RT t is going to be equal to R of t minus t, which is going to be equal to R of 0. So the derivative of R of t and t is going to be equal to the derivative of the E of x of t times x of t. So it's going to be equal to the derivative of E times x of t squared. And then we do we take the square outside of the parenthesis, so we get the 2 times E of x of t times the derivative of x of t. And as we know from the question 1, so derivative of x of t is going to be equal to just the y of t. So 2 times E of x of t times y of t is going to be equal to 0. So because 2 of them are 0, now we know that E of x of t times y of t is going to be equal to 0. C, are x of t and y of t aren't correlated? So from the theory, we know that if we want the x of t or y of t aren't correlated, they have to satisfy that E of x times y is going to be equal to E of x times E of y. So obviously from question B, we know that E of xy is going to be equal to 0, which is also equal to E of x of t times of E of y of t. So because of that, we know that they are uncorrelated. D, are x of t and y of t orthogonal? Well, the answer is yes, because the theory is that the E of x times y is equal to 0 in order to make x of t and y of t orthogonal. So we know that in this question that E of x of t times y of t is equal to 0. So x of t and y of t are orthogonal.